Now we have already discussed conservation of energy. Now we'll have to discuss the conservation of momentum in Compton effect so as to find out the shift delta lambda. Alright, so let's discuss the conservation of momentum. Alright, so we have photon, initially incident photon, and we have an electron. So let us first write the momentum of photon. The momentum of photon is given by h nu divided by c. And nu is the frequency. So this is the momentum of incident photon. The momentum of electron is 0 because it is at rest. So this is initially the momentum in x direction. The momentum in x direction. The momentum in y direction initially is 0 because nothing is happening in the y direction. The photon is going in the x direction, the electron is at rest. So momentum in x direction is written initially, is written as h nu divided by c. Now this is the initial momentum in the x direction, and well, the final momentum in x direction, momentum in x direction can be given as, first of all, let me draw the system. You have a scattered photon, and this is the reference line. Let me change the color real quick. This is here recoil electron, and that is phi. All right. So let's write the momentum of the scattered photon. The momentum of scattered photon can be given as h nu dash by c, but this momentum is not in x direction because this is at an angle theta with the reference line. So for the momentum in x direction, px final of photon can be written as h nu dash divided by c multiplied by cosine of theta. Now this is because we have taken a component of the momentum, and similarly we can write py final photon equals to h nu dash by c into sine of theta. So this is the momentum in x direction due to photon, this is the momentum in y direction due to the photon. Now let's talk about the momentum due to this recoiled electron in the x direction and y direction. So let us say that this recoiled electron has let me change the color. This recoiled electron has momentum p. Alright. Now the momentum of recoiled electron in x direction is equal to p cos phi, and the momentum of, now keep in mind that I'm writing the magnitude here. Here I have written the magnitude, here I have written the magnitude without the sign, and here also in case of recoil electron I'm writing the momentum. So p of recoil electron in y is equal to p sine phi. Now this is the magnitude, not with the sign. Now with sign, if I had to write, I would write it as minus times p sine phi. So I'll sum up this by writing the final equations of conservation of momentum, and wait a second, there you go. I'll write the equation of conservation of momentum in x direction. Now I can write that as h nu divided by c is equal to h nu dash divided by c into cos of theta plus p sine phi. Now this is, let's say, equation 1. Now the conservation of momentum in x direction can be given by this thing, this equation. Now we recall that this is the momentum in x direction of incident photon. Alright, incident photon, and this here is the momentum in x direction of scattered photon, and this here right here is the momentum in x direction of recoiled electron. Similarly, we can write the conservation of momentum equation in y direction, and let's do that. Conservation of momentum in y direction, and initially there is no momentum in y direction, and finally there is momentum in y direction as minus times p of sine phi plus of h nu dash by c of sine theta. Now what is this? This is the momentum in y direction of recoiled electron, and this here is momentum in y direction of scattered photon. Now equating both these equations, let me change the color first. Yes, equating both of these now we have conservation of momentum in y direction, we have conservation of momentum in x direction, and we have already derived the conservation of energy, which I can write as m naught c square plus h nu equals to h nu dash plus under root of p square c square plus m naught square c to the power of 4. So this is conservation of energy, and this is equation 3. Now with the help of these three equations we will find delta lambda. Alright, now I'm not gonna solve these three equations because that's gonna take a lengthy calculation. I mean, it's gonna take a lot of time, but I'll give you the expression for delta